everybody to this webinar about how to use Microsoft Azure in a hackathon. My name is David Schneider. I'm working for isolutions. And together with the Young Boys Bern, with the football club of Bern, we are organizing this hackathon for the third time this year. We expect about 70 hackers, which will work on about 8 challenges during 24 hours. And hopefully we will see some very cool solutions. Some of them will be based on Microsoft Azure. And this is why that we have now Edin Kapic in the call. He is a senior architect and SharePoint mastermind at isolutions, working in Barcelona, Microsoft MVP, and he will give us an introduction into the Azure platform and how to best use it for a hackathon. Thank you, Edin.
Okay, thank you. Let me see. The new normal is always like, do you hear me? Can I share my screen? Do you see everything? So I will just suppose that that's the case. And I'll go straight forward. So I have some slides prepared for this and also a lot of demos, a lot of eye candy, I hope. So my the session I prepared is has a really original title of how Azure helps running hackathons. And it's a little bit of what features from Azure, from Microsoft Cloud offering, help you as a hackathon participant to quickly build the solution that you have in mind without having to worry about deployment or infrastructure details. So I think there is a lot of value there in Azure that can help you as a hackathon member to really get up to the speed and think of what's unique for your solution and not to think about how to deploy or how to model something in cloud. So the agenda is going to be basically covering the bread and butter of Azure, which is app service, where all the logic, usually all the logic is placed. Then we'll see what options we have for storage and databases. Probably you're going to save your data somewhere. Then this being a hackathon, it's also very important to be very agile in deployments and quickly have a quick turnaround to get the latest version online to test. Then we have with Azure, there is a huge value proposition in reusing artificial intelligence and machine learning in your solutions. And I will show you how you can quickly use it in your applications. And then there is a whole spectrum of Internet of Things, which is also an emerging field where many new solutions and new propositions are being created. And Azure also has a lot of offering around this space. So welcome to the journey. Buckle your seatbelts and prepare for a quick journey over the Azure for hackathon members. So as I said, the first thing is app service. App service in Azure, I will show you just this in just a few moments. App service is a basic hosting capability. So this is a kind of a generalized hosting where you can host on Azure service. You can host your application. This application can be a web application, like a normal web application with a front end and the back end, or it could be just the back end. So it will be an API app or a normal web application. Then we have the mobile backends. If you have a mobile application or mobile prototype, then the mobile app is where you store in Azure, where you store your data and your loggings. Then we have logic apps, which are a quick way to connect different systems. Like when something happens on Twitter or some search pattern, then you want to fire your logic and then call your code that does something clever with that data captured from Twitter. And then you pass it through another service, and then the result is written somewhere else. So you can quickly make integrated things with logic apps. But probably you are going to use the web app backend as your hosting capability. In Azure, we can choose. We don't have to choose. Azure doesn't mean it's Windows. multiple technology stacks are supported. So we can have our, we can use the best technology that suits our needs, whether it's Windows, whether it's Linux, or many platforms, such as we have Ruby, we have PHP, we had Node.js, of course we have .NET and .NET Framework and .NET Core, but we also have everything in between. Almost every technology which is more used in modern applications can be used in app service. And we can choose between Linux and Windows app service, which means on the back end you get a Windows deployment or a Linux deployment. So you can run on what best suits your needs. And I have a quick demo for this. So I will show you this is an Azure command interface, or the portal. I have created a resource group, which is a grouping of things in the same, so to say, like in same folder, to show you. And the first thing is this app service. So I will make it a little bit bigger. In Azure, everything you do, probably you will do it from this interface, or you can also do it in the shell of your choice. If you are in Linux, use Bash. If you are in Windows, use PowerShell, or you also have a Cloud Shell, which is here, so you can run it directly in the browser, running on your backend. It's even better solution if you don't have to download anything to your computer. So this is just a quick introduction to what possibilities are there, but I will show you how this is done in user interface. So we have this app service. I have this Hackathon demo, Microsoft Switzerland add-in. You can choose when you create a resource, you can choose where it sits. This one sits in Switzerland. So if your solution has to do something with laws that require that your data stays in Switzerland, so this is you would choose this deployment. I don't know why Switzerland South is not supported. It doesn't let me create anything there. Probably they're still doing the data center. I don't know. But if you go to the app service, here I can see that this app service I created is there are some dashboard information. Oh, sorry about, I was too quick on clicking the mouse. So my application service is running. I have a URL, which is as expected from a hosting. And if I click there, I have a small application deployed there. We'll see if it runs. But in the meantime, as I said, here you can quickly check what's supported for your application. In my case, here I have settings, and here I can say this is Linux backend, so I don't have that many settings like some specific Windows things, but here you could put some change, allow WebSockets, disable WebSockets. Here we could put settings to your application, and I will show you other options as we go on. There is always, in the most of the Azure resources, you can choose a free tier or a very cheap tier. This one is free, which means my application is subject to some limitations, mostly how many times you can call the application or how many data you can put there. But for testing purposes, you are basically doing quick prototyping. So free is as good as price as you can get. And not all, but most of Azure services, as I said, they have a free tier. And you can do a lot of things here. So I can show you now that this application, I have a small, this is a Node.js application. It's not even .NET, it's not even server code, it's JavaScript code running on the server. And I can show you how easy it is to use. This is the source code. And you can see that this application is very, I'm not a super expert on Node.js, but basically here you create your application and then you render the index page, and then I have here the index view, and in the index view I say render, title is Express. If I change this to Hackathon, save, and then I'm in Visual Studio Code, which is also a free software. So here I can deploy to Azure. I can deploy this this solution directly to my subscription. Are you sure? Yes, I'm very sure. And it's going to deploy the solution, and we'll see just in a second that it will be updated. So you are working as quick as you can in your hackathon, and you have your one of the best editors you can get, Visual Studio Code, and it's integrated with all these extensions. So you can directly connect to Azure. There is an extension for Azure. You don't even have to leave this editor. This being said, I do prefer for many things, I prefer the UI, because you can do much more things, much more intuitive, thanks to the unified user interface. Let me check if this has in a moment this will be updated, so we can see that I haven't cheated you. So this Express.js application is running on a Linux subscription. But in the meantime, while this creates, usually if you are a Microsoft developer on Microsoft technologies, you will use Visual Studio as a full-blown editor. And from here, it's also very easy to create a new application. So I can create a ASP.NET Core web application. I will just say, okay, create just basic. It will be a web application, no authentication, everything is okay. Create. So I will create application and quickly deploy it to the same deployment slot as I had for the previous one. So we can it's going to be running also on Linux. So this application, if I run it in local, you will see that it's just a standard Hello World web application. And in a second, we'll see that this is going to run. Build succeeded. That's going to open a browser. But in the meantime, I could check if the previous one has finished. Let's check. It should say hackathon. You see, now it says hackathon. So I deployed from my, we were waiting for this. See, deployment completed. So directly from the editor in JavaScript application, I can deploy to Azure and see the changes in real time. So now I will keep this page here, but I will just check that my standard, this is the standard UI of ASP.NET Core Hello World application. This is built in. And I can now quickly, from Visual Studio itself, I can quickly deploy it to Azure. Just have to publish, choose Azure subscription, app service, select existing, and I have to choose where is it? Select existing. Come on. Okay. I have so many user accounts for this, so I don't know which one is it taking. But if I can't, this is Docker, Azure Virtual Machines. No, it doesn't let me. Okay, create profile, and then okay, now it asks me. No, I need my personal account for this. So it will ask me which subscription. It's I had to do this in the other editor, but it was more text based. So here I have not Microsoft account. Sorry about that. Okay. So my subscription is this one. My resource group should be. Why only this one? I should have resource type web application. It's not showing my latest web application. Okay, demo gods haven't been good to me for this demo, but stay tuned. I have another one, which is also a web application. It's going to going to work, but I don't want to spend more time than needed for showing the app service, because we have many more interesting things. I'll come back to this demo later. So second tier is storage and databases. So probably not only you need a backend and the front end and the page for logic for your application, you also need to save some data. In Azure, we have many choices to store the data. The basic one is a thing called Azure Storage. Azure Storage is a general storage mechanism that lets you store data in several ways. You can store data as a table, like a huge Excel file, so to say, with columns and rows, which is almost infinite in capacity. You can also save, if you have data which is in binary format, like images, text, binary content like files or videos or something like that. You can use blob storage, blob being binary large object, which is storage optimized for a huge amount of data in a binary format. And there is also file, if you are familiar with file shares in Windows or UNC shares in networks, there is also a level of abstraction on top of that, so you can use files. And one thing that people usually don't realize in Azure Storage that you also have queues. You can build a mechanism work or a backend mechanism working on queues, which will make it easy to scale up and down because you are not connected to the storage. You have some asynchronicity to it. But as you can see in this diagram here, Azure Storage really allows you to, with the queues, and it allows you to do a lot of interesting architectural choices, probably not as a part of hackathon per se, but your solution when it's out of the hackathon stage, if it's something that is worth exploring, then probably you will evolve the architecture to something more scalable. If you need a relational database like the old-fashioned, so to say, the SQL Server, you have SQL Azure, which is SQL Server hosted in Azure. There is also a free tier. There's different tiers of scalability. And then there is a Cosmos DB, which is a Microsoft Azure offering for a solution, storage solution, which can span multiple regions, you can store multiple types of data with several, you can save one kind of data in one part of that storage and another kind of data like graphs in another part of the storage. And it's very good. Even it's a little bit complex to understand all the options that you have, but so to say, it's a polymorphic, so it can have many faces, data storage. And I will show you that in a second. And of course, if you need storage like MySQL, MongoDB, Redis Cache, some other database solutions like Oracle, you still have all this available in Azure on the Azure Marketplace. So I've added here the screenshot of this Cosmos DB. We will see what you can store there, and I will also show you the storage options in Azure. Okay, so we go to Azure, to this resource group, and in the resource group, I have a storage account, which is this one. So inside the storage account, which I created just once, it's also in Switzerland North, you can have different redundancy options, like you can have it replicated in a different geography. So if something fails in your primary data center, you can go to another one, but this is something like for production, not for hacking, not for hackathons. And here I have the different storage options: blobs, files, tables, and queues. So if I go to the blobs, here you have a container. I created a container being something similar to folders, and inside the container, I can have blobs. So this one is a binary object. Of course, it's a PowerPoint presentation of 7 megabytes, and I store it in this storage, which is very, very cheap to keep things for a long period of time. And there is also a thing that you can change the different. You can have different actions you can do here. You can change it. You can delete it, and then you can also have it in hot or cold storage, depending on if you need it really responsive or if it's just for, so to say, for backup purposes. So this is for storing binary data. For storing tables, I have table service. So here I have a demo table, and inside this table I could store data. How you store it? There is a tool called Azure Storage Explorer, which is a free tool downloadable from Azure, and you can connect to your storage, and then you can use the table as it were just a normal database if you need to populate quickly some data for your hacking application. And also there are queues, so you can use queue to send messages, and here from the UI you can send a message. So you can send a message body, which is a text, and then the Azure will take care of assigning it a unique ID and keeping track of when it's inserted, when it's being read or being dequeued. So there is a lot of things that you can do only with this simple and very, very cheap storage, which is available in Azure. It's provisioned in seconds. You just click, 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 and that's it. And here you can open it in this Azure Storage Explorer, and then you can just quickly hack whatever data you need in there. And then there is the Cosmos DB, as I mentioned. I also have a Cosmos DB provisioned. I think it's also in Switzerland North. Yes. So in this Cosmos DB, you have also you store data in containers. So here I have a container, and by default you can come on, don't it's have to open it in the other one, in Document Explorer. This one, Data Explorer. That's the good part about Azure, that it changes. It's continuously evolving. So a thing called the Document Explorer, now it's Data Explorer. So okay, got it. So here I have my Cosmos DB database with a demo container. Inside I can store JSON documents by default. And here I have created a small JSON document. So this is as in a basic way, Cosmos DB is a JSON database. So you can save data in JSON format, and then you can do queries from here. So you can make, here it's select asterisk. So it's select everything, but I could do queries, which will then be translated to some Cosmos DB internal query, and then you will get from your JSON data, you will get information. And good thing is that for example, you don't have to have the same exact data in each of the items. So you could have another item which doesn't have a message but has another thing, and or has 5 or 6 properties and sub objects like I don't know, hackathon being another object with a name, Young Boys Hackathon. So you can then query things with sub-objects inside, which is very difficult to model in a relational database, but in Cosmos DB, it's a breeze. Cosmos DB, you can also query it in different languages. You can query it SQL, you can query it as a table, but that's a little bit more abstract to talk about now. But just to let you know, that Cosmos DB is when you need something which is not relational, or not only relational database, which it can be used for multiple things. And here we can see some statistics. If you need something else, as I said, here in the, when you add something in Azure, like here, when you add a resource, you can go to the marketplace, and here you can search all the data storage you need. So storage, you have Azure Data Box, HyperCloud for Azure, CloudBean, or databases. Here you have MongoDB Atlas, Sky Cluster. I don't know. There's some of those which they don't ring a bell, but here you can choose, okay, I want running on any operating system for any publisher, and you have a lot of options to add to your hackathon. So if you need something really specific, some really specific database or service, you can add it from Azure. Okay. What can we do about being agile in deployments? In Azure, you have multiple things that you can set up for making it much more agile for deploying the code that you are building quickly and during the hackathon to your Azure environment. There is a thing called deployment slots, which allows you to define in like here in this screenshot, you can define for each web application or each app service, you can define slots, which then you can deploy to one slot, deploy another copy of the code to another slot, and then you can swap them. So you can quickly do some testing, and then when it's okay, you can swap it with the live one. So then your testers are attacking the live deployment and not the. So you can do some hot swapping, which is a recommended practice to never have to reset your environment. It's always an instance of one or another deployment slot. You can have up to 5, I think. And then what I will show you is this deployment pipelines and continuous deployment from source code. So you have a source code repository, like here on GitHub or in Azure repos or Bitbucket or whatever, and then you connect to your Azure environment, and every time there is a source code change, you get a new deployment in automatically. And you can also deploy Docker containers, both for Linux and for Windows in Azure, or you can deploy your own containers inside Azure. Okay, I will show you this in the here in the app service. I have this app service with continuous deployment. It's another app service, also in Switzerland, should be web Switzerland North, yes. So here you have this deployment slots, as I mentioned, but you also have a deployment center. And the deployment center, here it will say that it's connected. I connected it to my repository, which I have here in my Azure Devops, which is also a good environment for managing your source code and managing your source task with Kanban boards, sprintings, automatic builds, automatic deployments, and testing. So here I have a Hello World PHP application, like here, Hello World. So it's connected. This is my Git repo, and it's connected to Azure pipelines for this demo to this web application. So if I go to if I open the web application, let me see where is it here? Here it should be the URL here. If I open it, it should say Hello World. If it runs, or if it decides, it's on a free tier, so of course it gets throttled a lot. So it says Hello World in PHP, but if in my source code I change this, I can change it online. I can say Hello World from Hackathon, and I commit. I commit directly to master, which is of course a worst practice you can do. And now, in just a few moments, this will be redeployed. If I go to deployment center, it should be redeployed, and I will have the fresh version. So here it says, okay, it's been deployed to production, and now it should. I don't know on what intervals this is. I think this is configurable, that you can configure on which intervals it polls the source code to see if it's something new, but you can quickly click synchronize, and now it will deploy the latest source code from repository. And let me see if it's not yet. Okay, so at least it's been triggered, and there should be. Oh, today is not the demo day. Everything works. Failed to deploy. Did I miss some? Okay. Okay. I haven't done much different. Strange. Let's check again. Okay, now it kind of works. I just refreshed, so there's probably some. Now it says it's okay. Oh my, okay. So it's as it is. It's updated from the latest source code. So now I have this message, which I have edited in a new commit 2 minutes ago. This is a quick way to actually get your latest source code automatically deployed in the background while you keep coding in local. And as I mentioned, the deployment slots, which are here, you can define, but of course I'm in a free plan, so I don't have this. This is a standard plan feature, which means you have to pay a little bit for it, but you get many other features like SSLs, custom certificates. But this is something that usually will work when you pass the hackathon phase and you go to something which is going to be deployed in production or test. Next thing I wanted to show you is the world of artificial intelligence and machine learning. Here you have two choices. You have cognitive services, which is like a self-service artificial intelligence that you consume. You call it with your data and you will get some results back. You don't have to do anything else. You can parameterize a little bit. So for instance, this is one demo. You have this handwritten note and there is a computer vision service and cognitive services. You pass the image or the URL of the image to the service and it gives you the text back, OCR for handwritten. It also recognizes handwritten text. So it got it like exact with the line breaks and everything. And if you have some specific machine learning knowledge that you want to model, you have the machine learning studio, which is something that looks like this. You add your data, you define your model to be trained, but you need some knowledge about machine learning for this. But just using cognitive services, you get a lot of value. For instance, you can recognize voice, transcript it to text, detect entities in this speech or in this text. So schedule appointment with Sam today at 1 p.m. So it will detect it's Sam, it's today and 1 p.m. and it's an appointment. So it will call your calendar service with those parameters. That's how Alexa's, Siri's, and Cortana's work. Something similar. This, and you can train it for your own service. You can make your own bot, voice bot, using cognitive services. I have also a demo for that. I have this cognitive services demo. I have, where is it? I have this program. I will open it in Visual Studio. I know why it always opens in the old Visual Studio, but yeah, it doesn't really matter. This is a console application, which is everything is in one method, which I start by using some images and then I call different cognitive services, computer vision services there. I'll show you what the code does first. Basically, it goes to these different sample images. One are celebrities picture, one is a generic picture. So here I can open the thing. So this is a dog. I can open the celebrity one. This one. Okay, read the text. Okay, so this is another image with some text on it. This is another image, which is a landmark. And what I do is I have this computer vision client, which is a cognitive services. Then I analyze the image. I detect objects in the image. I generate thumbnails for this image. And I detect celebrities in an image. Like in detect objects, I try to detect what things are there. And there is also a detect landmarks, detect celebrities. So in the celebrities, there is a photo of Satya Nadella and Steve Ballmer, like celebrities, so to say. And I think it's, which one is this? We'll see it now if it runs. So basically, it will analyze those images using cognitive services and we'll get some results back. So quick start example, analyzing the image. Make this bigger so you can see it. So it says it's a dog sitting on top of a grass covered field with confidence 93%. No, that's another one. So it's an animal dog. Okay, now it has finished, so now I can safely go back. So it's a dog basically with this coordinates. So it even has localized the dog inside the picture. It is not adult content. It doesn't have any racy content, no celebrities, no brands. It even says which are the dominant colors in the picture. Then the other one is, okay, what is this? Sample 9 is a skateboard with a person. And then the domain specific one, this landmark is a Colosseum. It knows that it's a Colosseum. It has a database of landmarks, and it can check if it's I don't know, the Alps, or is it a Roman Colosseum, or is it I don't know, Atomium in Brussels. And then celebrities. Steve Ballmer is here, Satya Nadella is here, and Bill Gates is in this photo there. And also is able to create thumbnails and read the label that I had, the picture, saturated fat, total fat, so it can read the labels. And you see how easy it was in just a few lines of code to get this running. All these examples are available on Azure Samples and on GitHub, so I didn't have to reinvent the wheel. This is something you can get started just in cloning the repo and then just adapt it to your needs. Okay, so yes, this is the dog that we detected. Okay, how are we going with the time? Ah, good. And the last thing I wanted to show you is the Iot Internet of Things, which is now this possibility of having devices, smaller devices, not only mobile phones and computers, but also smaller devices integrated with sensors to connect to internet to send data to our backend for processing. So if your solution has to do something with physical sensors, probably you can use IoT offerings from Azure. First offering you have in Azure for IoT is Iot Hub. Iot Hub is communication infrastructure. So it allows you to easily send data from your device to Azure, and then to route this data, filter this data, aggregate on this, add some business rules or statistics, and it comes built in. So it's a very simple way to send the data to Azure, but also it's a two-way communication. So you can also deploy data, send data to your devices, or for example, you can upload firmware to your devices. You can upload your code running on different devices on different places from one central place. So Iot Hub is the messaging infrastructure, communication infrastructure. But there is another offering which is interesting. Hey, what is? Oh, I just added the slide in the wrong place. Sorry about that. There is a second offering, which is Iot Central. Iot Central is a capability to define applications on top of on Iot Hub. So you can have your own application portal, and you can build like something similar to business intelligence dashboards, where you can click and see data. But here, the data is coming from your IoT devices. You can see, for instance, this is the refrigerator number 2. So you have the metadata about the machine, like this is a serial number, what's the temperature, what is the trend of the temperature, minimum humidity, whatever, or even you can go to the IoT device itself, check the sensor data. Of course, this runs on top of this Iot Hub communication, but you can also define business rules and visualizations and hierarchies on top of that. So you can make something that looks like something like this. This is a remote patient monitoring system deployed on Azure. So you can reprovision patches to the machines, braces. You can see the battery levels on the devices in hospitals from one centralized location. So for if you build something that has to manage or has to collect information from many devices, this is a very interesting proposition. Another thing you can use for IoT is a notification hub. which is a capability of sending messages to devices. Devices in this case meaning usually mobiles or tablets, but you can use notification hubs to send from your backend. You send just one message to notification hub, and then each device will get its own version of native notification, like push notifications, being it iOS device, Android device, Windows device, Apple device, whatever. And then you can get some, you can do some test sendings. You can check statistics and check failures in your delivery. So how many pushes you have per month, how many devices you can send. This is how it looks, the notification hub in Azure. And last but not the least, for the brave of you, you have Azure real-time operating system called ThreadX, which allows you to build devices which function on real-time monitoring, something like, imagine software which is built in medical devices or in factory devices that has to work on real time and read some sensor data, send some telemetry data, and also allow user interface. So you have also this different devices. You have a Azure real-time operating system studio, so you can build your graphical interface, and you can quickly build your integrated device solution in Azure. This is of course much more complex than just consuming Hub or consuming the Hub Studio, but it's very interesting that you can also model something as complex as your own real-time program that has to be run on top of these Azure capabilities. And I will show you the IoT Hub demo, which I also have here, one IoT Hub in this, where am I? In this resource group for the hackathon, I have IoT Hub, which is here. And in the IoT Hub, I have one simulated device, which you can see here that I have sent some data. If I put this to 7 days, you will see a peak when I was testing this solution. And this is, as I said, the IoT Hub is the communication infrastructure. So I define the IoT Hub. It gives me some properties and endpoints, which then I can feed in my application. So here I have, where is it? It's here, IoT. I have a simulated device, which is a .NET program. Very, very basic. It simulates an IoT device and sends data to IoT Hub every second. Some simulated data, so I will use .NET Run. It's a application which only has one file, and now it's sending a message to the IoT Hub. It's sending some temperature, humidity data, of course, totally random. But if I refresh here, it has some delay, but I will get number of messages, how many messages are arriving. But this is the sending part. I can also use IoT Hub to read the data. So for this, I have another program. It's also in the IoT demo on GitHub. This small program reads those messages from IoT Hub and process them. So here I can open another command console and run .NET run. Chooses .NET Core. So here I have a device, so to say, device sending data. Here I have a device reading data, and you can see that this. Oh, sorry for that. It's actually, I get some scrolling. So I get message sent, message received. So I can have, you can imagine the left part being a real device and the right part being your backend that has to react to some messages. And this is, of course, almost infinitely scalable because IoT Hub in the middle, you can make it as big or as small as you need. And you don't have to build it by yourself. Okay, I think that with this, I have covered more or less all the scenarios that I wanted to show. The only thing left was this basic web application, which was not being able to deploy to Azure, but I could try to get it running, but probably it's some very, very basic error. Yeah. I had, are there any questions, anything that you would like to see beyond this demos in this things that I already prepared? So you can here you can see that the app service is of course Linux. It has the penguin on it, running in Switzerland. The only thing that I couldn't provision in Switzerland was Iot Hub, which was not yet available in Switzerland. So the closest one is West Europe, which is Amsterdam. Not that close.
I had a question.
Yes.
Hi, this is Daniel.
Yes. Hello.
Just wondering, in the hackathon, we also have challenges that require mobile apps. And you showed with the, it was, I believe, App Center, was it called?
Yes.
Right? The web apps part. And
yes, there is a mobile app part. Yes.
Oh, okay.
I can show it. Yes, there is a, in the resource group, you can provision. It's an app service, but then you can also add, I think it's still supported. It's called mobile app. No, it's not here. It's not there, mobile app. I think they kind of changed the name because this was the backend capability on the app service. Mobile, no, it's a web app. It was an app basically, it was a compute. Check. Where was it? No, it only has those. Let me see if I can get it from here. And here there was a Internet of Things. No, IoT, no.
It's gone.
Probably in compute. Let me see all. Sometimes it's really difficult to find what's in, what's out. Featured operating systems, cache all compute. No, this was called mobile apps. So I'll just check.
Yeah, I think they changed the name. Now they have this notification hub for the push messages.
Yes,
but,
that's.
For the rest, I don't know.
But there was essentially a mobile backend as a service.
Yes,
right?
you could save data. You could save authentication data or some profile information per user. Also get the backend data and push notifications. So push notifications that they moved to notification hubs, but the other two, I'm not sure if there are any.
But
if there is any backend.
Wouldn't give us any help in terms of creating the UI, right? The front end.
No.
It would still be some sort of framework that we had to choose. Okay.
That's correct. This being said, what you can get is, for instance, if you develop for Android or iOS applications, you can have Azure pipelines to build on iOS devices or on Android devices, running on Microsoft Cloud. So, for instance, I know that if you build iOS application, it can only be built on a Mac, but in the pipelines, which is the build engines for Azure, you can have you can create a new pipeline, and you can create a pipeline which is so you say, okay, I have Azure repos.
It uses
blah, blah,
Mac
yes, and then you can have
right?
yes, you can have different builds, and then there is a Mac, so you can have different build processes. And I know there was a Mac one.
There's the Xcode at the very bottom.
Yeah, Xcode, yes, on macOS, yes. Xcode, and then you define it, and then it will automatically use the latest virtual machine image of macOS, and it will run on the simulated Mac, which is a cool thing. You don't have to do this yourself if you don't have a Mac.
You still have to do the UI, right? That's
yes. But at least the build part, you can do it in a you can do the UI, you can do it in emulator, but then emulator for Mac, you need the Mac, but you don't need a real like small Mac to build things.
Cool. Thanks, Edwin.
Yep. So I think there is a lot of value in using even the free offerings or the trial offering, because you can also get a trial. You get some credits for using the Azure functionalities, and you also have Azure Devops, which is this source code repo and the tasks management and build management part. So with two of them, you can quickly set up your infrastructure and concentrate on coding, which is the important part.
Azure Apps already, no, what is it called? App Center. It already had the CI/CD built in, right? Is that Azure DevOps? Or is it that
Azure DevOps is the former Visual Studio Online, which is the former Team Foundation Services. So it was the TFS Online, then Team Foundation Services, and then Visual Studio Online, and now it's Azure DevOps.
So that's the one we should use, right?
Yeah.
It has CI/CD built in and everything. Okay, got it.
Yes, this one has the repos, it has the boards with the work items, backlogs, and everything. You also have a pipeline. So this is build, this is release. You can have artifacts, which is your own packages, npm, NuGet packages you can build here, and then you can have test plans, and you can have even a whole a bunch of virtual machines where you can deploy your tests and run your test automatically, UI tests, load tests, or for unit test, you can integrate it in the build, so you can see the unit test coverage. Most of the test frameworks are covered, so it's a very nice capability. I think it's free for teams of 5, up to 5 users. So you can create a repo and you can have up to 5 users free. And usually for the hackathon, you don't have more than 5 users.
That's correct. Thanks, Eddie.
Yep. Okay.
Yes. Thank you. Thank you very much, Erin, for this nice presentation. A lot of demos. I really enjoyed it. Just a side note is there will be a coach of Microsoft at the event at Hackathon. So if you have any questions about like how to use these Azure services or what Azure service to pick to solve the challenge, you can ask the coach on site. And we will also provide Azure passes, which allows you to or credits for Azure, and then you can build an Azure subscription and use that during the hackathon without the need to provide a credit card to create the tent. Yes, that's it. Thank you very much, Edin. Thanks again.
And sorry for the demo gods.
Yeah,
it was like it works, but then it's live, so.
It's live. You did a lot of demos, so that can happen. No worries there.
Yeah.
And thanks a lot. And like most of you, I will see on Friday at the YB Hackathon. See you. Thank you.
Thanks, guys.
Have a nice evening. Bye-bye.
Bye.